So today we're going to talk about volume. We did take a look at different figures, different three-dimensional figures that are three-dimensional figures that we're going to see in this video. So the first one here, let's start off with this one. The volume of an object refers to its capacity. How much could it hold? How much stuff? So when you're talking about volume, it's what's the inside that's gonna count. Okay, how much stuff can it hold? What's in the inside? So volume is measured in units cubed or cubic unit. For example, we'll see that in a second. Example 1, determine the volume of a cone. Now, the volume of the cone, just like when we talked about the area measurement, calculating the area, volumes also have a formula. Okay, so let's take a look at this one here. So the volume formula, you're going to be given this all the time, okay? But if you memorized it, that's great. So the very first one on page 10, this one here is a rectangular prism. So the volume is the amount of space inside where it can hold stuff are based on these three things. It's based on the length. What do you think the W is? Wide, how wide it is, right? And the height. So we know those are the three things that we need to know to figure out how much stuff that can be put in the box. You need the length, the width, and the height, right? So length, width, and height. And this one here is a triangular prism here. So here's a formula for that. It's 1/2 times length times width times height. Yeah. Or you can say length times width times height divided by 2. Okay. Now, do you visualize why it's divided by 2? Why is it divided by 2? We want to make sure that we understand that piece. So what does that started off? It started off with length times width times height. So that kind of reminds us of a rectangular prism, right? A box. So that kind of reminds us of a box. So what I'm going to do is I'm going to draw a box. Okay, so now I'm going to put my drawing skills to the test. I did practice. So here's what it's gonna be. You don't have to do it, okay? I just want to show you why it's a half. So started off with a rectangular prism like that. Okay, so you get the length, the width, and then the height. Now, why is it a half? And that's the main thing that I wanted to make mention is why is it a half? Well, if I cut this over here, right? What happens? And I cut that part there. It becomes a triangular prism. I'm going to try to make it look like a... So this is when my drafting school is paying dividends. Yeah, like that. So now you started off with a rectangular prism. If you cut it in half, then now you would have a triangular prism. Okay? So now I want us to take a look. Oh yeah, I know where that 1/2 came from. Okay? So because you started off with a rectangular prism, and if you cut it in half, that will produce a triangular prism. Now let's go to this one in here. Square base pyramid. It's gonna be 1/3. They didn't put the times there, so if you want, you can put times. So volume is equals to 1/3 times b squared times height. Okay, so 1 divided by 3, so 1/3 times b squared. Now, what does that mean, b? Base. So the base is here, the length of the base. And then we're supposed to square that. Squared to exponent 2 times the height. Okay. Now, do you notice that the height here is in the inside of this pyramid? The height is in the inside. And I don't know if you remember that. Remember when we talked about measuring someone's height? It has to be upright, right? And the way you could get the upright one is if it's coming from the top of the pyramid all the way down to the base. So 1/3 times base squared times height. Then I'll talk about the third later in a second, okay? Cylinder. Okay, well, what's a cylinder? What do we need to figure out the volume? So pi times r squared times height. Remember earlier I said, how do you increase the volume of the cylinder? And you said, I have to increase the bottom, which that means increasing the radius, and we could also increase the cylinder by increasing the height. Well, you are right on in determining the volume. You need the radius and then the height. It's radius squared. Okay, now here's another one. Cone. So cone is 1/3. I'll just write it here. 1/3 times pi times r squared times height. Okay, so those are the things that we need to consider. R squared, so we need to increase the radius, and then we need to the height. Now, do you wonder about something? You notice about the 1/3? Yeah, okay. We're wondering about that. What is that 1/3 about? Okay, what is that 1/3 about? We'll talk about that in a second. What is this part here? What does this remind you of? Pi r squared times height. Cylinder. It kind of reminds us of a cylinder, but then there's a 1/3 there. Okay, interesting. And then here, sphere. Sphere. These are 4/3, so 4 divided by 3 times pi times r cubed. R cubed. Okay, r to the exponent 3. So let's take a look at, so now we have the formula. Okay, we're going to switch back and forth in here and we'll do the formula as we go. Now, going back to page 9. Now that we talked about the formula, we can use the formula to figure out the volume of the cone. So, example 1, determine the volume of the cone. Okay, volume, cone. So, because we're talking about figuring out the volume of the cone, we're going to look at the volume formula of the cone. So, V is equal to 1/3 times pi times r squared times height. Okay, so this one here, 1/3 times pi times r squared times height. That's the formula that we're going to use. And then from here, well, what do we know? Do we know, well, 1/3, that's good. Pi, we know what pi is, 3.14. What is the r? Do we have the r?
Yes, 6.
Yes, we have it as 6. And then h, do we have the h?
9.
It's 9. So we have all the information in here. Let's go ahead and do the substitution here. So 1/3 times pi times r squared, so 6 squared times 9. Okay, so I'll give you a moment to type that in to your calculator.
The 1/3, is it like 1 divided by 3?
Yeah, you can just enter 1 divided by 3 times pi times 6. Okay, make sure you put the square there, times 9. Okay, so while you're doing that, okay, keep. All of a sudden I got thirsty. Okay, so what did you get?
339.29.
What did you get? 339.29?
0.29.
Okay. So 1/3, 1 divided by 3 times pi times 6 squared times 9. Okay, so you got 339.29. Okay, now the unit. What's the unit? This one is centimeters. This is centimeters.
2.
This is going to be centimeters cubed. Cubic centimeters. Yeah.
Because of that 1 divided by 3?
No, because here the radius is squared, right? So that means centimeters and then squared times another centimeters. So how many centimeters do we have? There's 2 centimeters here and there's 1 there, so that's centimeters cubed. Okay, now look at that one. Where did that 1/3 come from? I'm going to show you what's 1/3. Okay? If you look at that one, you said earlier that pi r squared times height reminded us of what? Reminded us of cylinder, yes? Yeah, that's the volume of cylinder. Now, how much of these do I need to equal to this? Maybe half?
3.
So I need 2 of these to make 1 of these? How many? You're thinking 3? You're thinking 3? Okay. So we'll see. 1.
Where are you going to put it?
Where am I going to put it?
Well, I can hang on to your post.
Let's put it right there. 1. Okay, I have to do it more, right?
Because it's 1/3.
2. 2. I didn't put, enough on the other one because I'm scared it's gonna spill it. Yeah, not three. So this one is really a third of this one. That's where that 1/3 comes from. Okay, so that's where that 1/3 comes from. I'm gonna put it up here so I don't forget.
Who is drinking, you be cut off.
Huh?
I said, who is drinking, you be cut off.
Oh. Totally drinking. Okay, good. So I just showed you that if you have a similar cylinder and turn that cylinder into, narrow it down along the top to make it a cone, you will end up a third of the volume of that cylinder. Okay, so that's where that 1/3 came from. Let's take a look at number 2. Determine the volume of a cylinder. How much juice can the container hold? Okay, so volume, cylinder. So what's the formula for volume of a cylinder? V is equals to pi times r squared times height. You can see here how much juice can it have? So do we have the pi? Yes. Do we have the r? Yes, we have the r. Do we have the h? Yes. So we'll use those information. So pi times r squared, so 4 squared, times height. Height is 23. Now this is not so bad. So go ahead and figure that out. I'll do the same. Did you get
1,156 and 0.11.
0.11 joules.
okay? 1,156.11. What's a unit? cm cubed. So every volume, it's gonna be cubed. Volume is cubed. Now, can I tell you something? When you buy a liquid, like juice or pop, the volume or the amount of pop in the can, are they measured in cubic centimeters? No.
5 kilograms.
Yeah. The unit is usually in liters, yes? Yeah. So what does that mean? So 1,000 cubic centimeter is equal to a liter. So what does that look like? 1 liter. So this one is gonna be about a liter, a little bit over a liter of juice. Okay? That's probably something that you'll learn in science, right? Yeah, because the juice can, try looking for cubic centimeters. It doesn't say cubic centimeters. It go by milliliters or liters. Let's go to example 3. Can you see here the question, how much air would be needed to fill the basketball shown below? If we take this off, okay, and then let's say this is a question from an assignment, or if this is something that we're going to be figuring out, the question says, how much air will be needed to fill the basketball below? So that's, where's the air? Well, the air is in the inside, right? So that's calls for volume. So what's the formula? V, volume, is equal to 4/3 times pi times r cubed. Yeah. 4/3 times pi times r cubed. Well, 4/3, that's just a number. Pi, that's a number. R, do we have that?
Yes.
Yeah, it's 9.55. So we're gonna substitute that 9.55 inside, or right here. So 4/3 times pi times 9.55 cubed. So let's go ahead and figure that out.
3,640.
Okay. I got 3,648.37. Okay, what's the unit? What does this unit mean? Inches. So you can go inches cubed or cubic inches. So this means inches. Is that good? Yeah? Okay. Let's take a look at number 4. Yeah. This one doesn't even have a picture. Okay, does it matter? So here, it says here, in a manufacturing, if a manufacturer wants their shipping boxes to have a total volume of 720 cubic centimeters, and the base of the box measures 15 by 8 centimeter, what should the height of the box be? Okay, let's draw ourselves a 3-dimensional box. Okay, is everybody okay with making a box, like a 3D? The one that I make? Okay, so I'll show you how to do this 3D. Okay, so draw a slant. And then draw another slant. Okay, make sure they're parallel. Okay, so that's gonna be part of the top of the box. So now complete that. It has to be the same length. Now you're gonna end up with a parallelogram. And then you draw a line down, all the same length, and then draw it up. So we have here a 3-dimensional box. It takes practice. Yeah, that's okay. 3-dimensional box right there. Now, we want it to have a volume of 720 cubic centimeters. Okay, we want to have it so that how much stuff can you put in here? 720 cubic centimeters. Do you know? I'm pretty sure you've seen this sugar cubes. Have you seen those sugar cubes for your coffee? Yeah, right? You take the cube, and that's 1 cubic centimeter. It's like really, really tiny one. Like for your coffee. So that's 1 cubic centimeter, right? Approximately. So when you think about that, 720 cubic centimeters, so that means you can fit in 720 of those little cubes, those sugar cubes. So let's take a look. The base is 15 by 8. So the base, this is the base, 15 times 8. We don't know what the height is.
6.
So how can we figure that out? So volume of this rectangular prism is length times width times height. What do we know? What do we know? Do we know the volume? Yes. Do we know the length? Yes. Do we know the width? Yes. Do we know the height? Not yet. Okay, so what we're gonna do is we're gonna put the values in here. So 720, length is 15, times width is 8, times height we don't know. Can you make a guess of what the h is?
6.
You think it's 6? Oh, you know it's 6. Okay. Did you solve it algebraically?
No, I just did process elimination.
Oh, okay. Yeah. It's good. It's good. Okay. So, do you think reasonable answer? Okay. So it'll go, okay, if I go 15 times 8 times, I'm going to make a guess. I'm going to say, I'm going to guess 3. Okay. Do you think the height is 3? I go 15 times 8 times 3. Is that enough? No, right? No? Okay. I'm going to try 4. 4. So 15 times 8 times 4. Got 480. Oh, still not enough. I need to go up to 780. What if I go... You just want me to go to 6 because that's the answer that works, right? I'll go to 6, okay? Just because you say 6. So 15 times 8 times 6. 720. Okay. Yeah, it is 6. So that means the height is 6. Now, that's a strategy. That's one strategy that you can try. Can we think of another strategy? What do you mean by process of elimination? How did you do that?
Just like we did.
Oh, you did like trial and trial. Okay, good. Can you think of another one? Do you have something? Yeah? Okay, tell us.
215 times 8.
Okay, so do 15 times 8. Okay, so I'm following one strategy that Ahmad is saying. So 15 times 8, do this operation. 15 times 8. What's 15 times 8? 120, right? Okay, so what happens when I do that? 120.
Divide to
720, okay. So this one here is 720 equals to 120 times h. So what he's trying to do is trying to do the strategy of solving an equation, right? Isolating the variable. And I think now people are saying, oh yeah, we could do that. 120 times h. How do I have the h alone? Divide by 120. I gotta do it for both sides. That cancels, that cancels. So that means 720 divided by 120, that's gonna give us 6. So it's gonna be 6 equals to h. Now, 6 what? What's the height? 6, what unit? Centimeters, right. 6 centimeters is the height. Very good, very good. Let's take a look at example 5. A square-based pyramid has a volume of 48 cubic centimeters. If the base of the pyramid is 4, what is the height of the pyramid? Sometimes it's a good idea to draw the picture, okay? Because when we see the picture, we have a visual, it makes it easier to kind of solve it out. So square-based pyramid, how do you draw a square-based pyramid? I'm gonna try to do the same thing. I'm gonna try to do the square. Starting off with a parallelogram. And then I'm going to put a dot on the top. And that's my point on the top. And I'm going to take that point and draw the line on each corner. There you go. There's your pyramid. It's pretty easy. Pretty easy to make. So what does that say? So the volume, that means how much stuff that we can put in there, is 48 cubic centimeters. Now the base is 4, so that means this is 4 centimeters. What is the height of the pyramid? So let's see. V is equals to 1/3 times b squared times height. That's our formula. Okay, so height is inside. Height is inside. So what do we know? Well, we know the V, we know the volume, we know 1/3, we know the B, we just need the H. Okay, so let's do that. 48 equals to 1/3 times B squared, so that's 4 squared, times height. Do you want to make a guess, or do you want to do trial and error, or should we do this algebraically? Yeah. Should we try it algebraically? Well, why don't you guess? Why don't you make a guess first? What do you think it is?
Morning, one sorry for the interruption. Students, you're welcome to attend the presentation from the RCMP today at 12 o'clock in the student lounge. The RCMP are hiring, so come on down and learn all about it.
Don't do it, you guys. You guys stay cool.
I heard they have a very good pension. Just
Yeah, if you gotta make it that picture.
If we live to see that.
oh no. Okay, I'm gonna make a guess. I'm gonna guess 3. Okay, I'm just gonna guess 3. See here. Okay. So 1 divided by 3 times 4 squared times 3. Oh, I got 16. Okay, that's not enough. Okay, can I try 5? I'll try 5. 1 divided by 3 times 4 squared times 5. Oh, I got 26. Okay, so I keep trying. I could keep trying and trying, right? I'll try 6 again. Or 6. 1 divided by 3 times 4 squared times 6. 32. Oh, that's not enough.
Okay, let's see.
Oh, let's see.
48.
Did you figure it out?
Bracket 1.
Huh?
48 bracket 1.
48 bracket 1. Okay.
Times 42 squared.
Okay. No, we're trying to figure out the h so that when we do this part here, it's going to equal to 48. Did you figure it out? Huh? 9? 9? Okay, we'll try 9. Okay. So 1 divided by 3 times 4 squared times 9. There you go, 48. So the h is 9. Okay. So this one here, that's a strategy, trial and error, right? Okay. But is there a better way? Yeah, there is a better way. We could do this algebraically, right? Solving for h. So 48 is equals to 1/3 times 4 squared. Okay, what's that equal to? That's going to give us 16 thirds. Okay, how did I get that? 4 squared is 16, and then the numerator times 1 divided by 3, 16 thirds. Now you might go like this, 1/3 times 4 squared. It's going to give you 5.333333, right? So 48 equals to 5.3333333333 times h. Okay. There's lots of 3's there. Okay. So this is what you have on your calculator, 5.333. What do we need to do to solve for h?
48
Divided by
5.333.
3333333. Okay, so I already have this 5.333 in my calculator. Okay, so what I can do is I can go 48 divided by answer, because I think most of our calculator have that answer ability, right? So the previous answer was 5.333333, and that's equal to 9. So 9. Oh, I forgot to divide by 5.333 here too. So height is 9. 9 what? 9 centimeters. Oh, how did you do it differently?
I did 48 divided by 1 times 3 divided by 4 squared.
Oh, okay. Oh, okay. Hold on. Tell me again. 48.
Divided by 1 times 3 divided by 4 squared.
48 divided by 1.
Times 3.
1 times 3. Oh, okay. Times 3. Okay. Divide by 16.
4 squared.
Oh, divided by 4 squared. Yeah. Yeah. See. Okay. Awesome. That's great. That's great. So there are some questions for you to try. Please try them. Right? There's some questions in here that you need, that has a picture, and then there's some questions in here that has the word problem. Okay? So please give those ones a try, and then we'll see you again tomorrow.